Hello and welcome to this video tutorial where we will have a look at first going through your frequency and time period questions. What I would suggest doing is having your worksheet open, going through it alongside the video. You can obviously pause the video when you want to, edit in questions, check your answers, make any changes that maybe you need to make so that your worksheet by the end of this video matches my one in the video, and that way you'll have all of the correct answers in one place. You would have read through all of this, which has a couple of worked examples in there to do with conversions, and we'll make a start by going through the questions, which starts off with what is the definition of frequency, so a little bit of recap from the previous lesson on waves and their properties. So how would you define frequency for this 1 mark question? Essentially what you have to say here is it's the number of waves passing a point per second, or you could say the number, you have to write both of these but I'm just going to put alternatives, the number of complete oscillations or maybe even vibrations per second. Let's just have a look at kind of how that really works. So if I just go back to the wave simulator, I'm just gonna let's put that into slow motion, and in fact we'll pause it right there. So if you consider, let's get this to this equilibrium point, which is that dashed line. Okay, so this bit here, which is doing the oscillation, and you can see that little dot, maybe think of that as a handle for that wheel, is exactly east of the screw there. And we would say that that is the start of this new oscillation, the start of this new wave. So there's different ways you could track it. So you could track it in terms of this peak here. So by the time that peak's gone and we've got another peak there, that new peak, that would be one complete oscillation. Or obviously this other way that we can look at it is we can think of the dot or the handle, which is currently east of that screw. Once it's made one complete rotation, an oscillation, that would also be essentially the time period. So we could have a look at, right, if we went for 1 whole second, if we could time this, we could figure out how many waves are passing in a certain time. So if we just play this in slow motion, you see that's 1 rotation, 2, 3, and so on. We'll get to kind of, well, it's 4, we'll get to 5. Now we'll go on a bit more just so I went past it, and 6. So 6 full oscillations, or 6 complete waves, took 4 seconds. So that means that if we did 6 divided by 4 to give us an answer of 1.5, we know there's 1.5 waves passing per whole second. And we can test that out, because if we know there's going to be 1.5 waves passing per second, then in 4 seconds more, to get to 8 seconds, there should be again 6 full rotations. So again, we can try that out, we can test it out. Okay, so that's 1 rotation, 2, 3, 4, 5, and 6. I've just gone slightly over there, but again, we know that this is working. And another way that obviously we can match that is here, where we've got frequency, it does say 1.5 Hertz. So we're expecting to have 1.5 waves per second. We can change that. So we could change that frequency down. We can move it to 1, and we should then get 1 oscillation per second. So you see it's slower. You could follow that kind of peak and the position of that peak here. And so now we've got 1 wave passing this particular point every second, or 1 complete oscillation by watching this little handle move around. And you could do the opposite. You can go on up the frequency. We could have that as 2 and we'd get 2 waves. What's the maximum here? Let's see if we can push it. We push it to 3. should get 3 complete oscillations per second. If I just reset this, it's 1, 2, and 3. And I forgot to press play on the timer. Let's try that again. 1, 2, and 3. Just gone slightly beyond again, but again you got 3 complete waves, or 3 complete oscillations in that second. And so what do we mean by our next question, which is time period? I'll just keep using this animation until we're there. Essentially the time period is how long does it take for one whole wave to pass a particular point, or how long does it take for one complete oscillation. So we know that here we've got a frequency of 3 Hertz, and if we just play this in slow motion, that took just under 1/3 of a second for one complete oscillation. And again, meaning that our time period is 1 divided by 3, or 0.3 recurring seconds is our time period. It's how long it takes for one whole oscillation or for one wave to pass a point. So we just go back to our worksheet here, and for time period we can put the time taken for one wave, we could say one complete wave to pass a point, or a particular point, or again you could say the time taken for one complete oscillation. And it's really useful to then use this equation, or this equation triangle, whichever way you prefer. We can say frequency is 1 divided by time period, and as we saw within the animation, they are linked, they are related. We could see that live within the wave animation. So let's apply it. Using the equation triangle, write out the equation for time period. So we know that frequency is 1 divided by time period. Cover up the f, you're left with 1 over t. So this time we want the equation where time period is the subject, so we cover up the t, and we're left with 1 divided by f. So we can put here t, which is time period, equals 1 divided by f, which is the frequency. So if a wave has a frequency of 10,000 Hertz, how many waves will go past a point every second? Well, Hertz is just the way that we measure frequency. Frequency, we said, is the number of waves passing a point per second. If we want to know how many waves will pass a point each second, we're just stating the frequency, which is then 10,000 for this question. What's the time period of that particular wave? And that's where we're going to use this equation here. Just to make it easier to reference back, I'm going to highlight that one in blue. In fact, these other answers, just to make that easier, let's go with green, and that way you can check it against your own worksheet more easily as well. So what's the time period of the wave? We're going to use our equation from before. So t, put that in bold, equals 1 over f, time period equals 1 over frequency, and so our time period is going to be 1 divided by the frequency, which is here as 10,000 Hertz, so 10,000, and let me just bring up my fancy calculator, emulating software, so 1 divided by 10,000, and we get that as 1 times 10 to the minus 4. Now you can put in 1 times 10 to the minus 4, and if you feel like you want to be a little bit fancy, it's control and then the dot, or the full stop. For some reason I have to use the one on the numpad. So 1 times 10 to the minus 4, and think about what the units of that will be. Because it's time period, we're looking at a measurement, as we saw within the animation, in seconds. So we can say 1 times 10 to the minus 4 seconds, or if you wanted to, you could write that out as a decimal as well, and either of those is fine. If one complete wave takes 20 seconds to go past a point, what is the wave's frequency? So one wave takes 20 seconds. Think about, is that the frequency of the time period? So that will be the time period, which is the time taken for one complete wave to pass a point. So it takes 20 seconds to pass a point, meaning that our t, or time period, is 20 seconds. Now we go to our equation. We want to know the frequency. Go back to the equation triangle, cover up the f, we're left with 1 over t. So we've got frequency equals, I'll keep that lowercase, 1 divided by t, which is 1 divided by 20. Bring up the emulator. 1 divided by 20, and we get our answer as 0.05. And the units this time is hertz, because we've worked out the frequency, the number of waves passing a point per second. If 200 complete waves go past a point every second, what's the frequency? Again, think back to that definition. Frequency is the number of waves passing a point per second. So we're told here then that the frequency is 200 Hz, no calculation required. Again, I'll make sure that I'm highlighting these as I go along. And as it often tends to be with part questions, the next part uses some information from the previous part. So now it says, what was the time period? So we're going to use this equation here. And in fact, I'm going to cheat a little bit and just copy and paste it. So we've got time period equals 1 over frequency, or in other words, time period is going to be 1 divided by our 200 Hz frequency. And again, I'll bring up the calculator. 1 divided by our 200 gives us an answer of 5 times 10 to the minus 3. So put there, t equals 5 times 10 to the minus 3. Again, that would be in seconds, or if you wanted to, you could give the answer as 0.005 seconds. And giving it as a decimal or giving it in standard form is completely fine. If you did want to use that power, you just highlight the bit of text that you want as a superscript, and then hold down Control if you're using Windows and the full stop. If a wave has a frequency of 6 kHz, what is its time period? Now note 1 kHz, otherwise known as 1 kilohertz, as you can see back in this worked example bit, is 1000 Hz. So straight away we can say here that our 6 kHz is 6,000 Hz. That's our conversion, times by 1,000, giving us 6,000 Hz. Then we go back to our equation from before, which I'm just going to cheat again and paste it. So time period is 1 over frequency. That means the time period is going to be 1 divided by 6,000 this time. Again, bring up the calculator. 1 divided by 6,000, and we've got 1.6 recurring and a 7, and I'll talk about that in a moment, times 10 to the minus 4. So you might be tempted to just put in 1.666666667, which is probably more than there were on the screen, times 10 to the minus 4. However, what I'm going to recommend you do, just break that down to a 3 significant figure answer. We'll go 1.67, just going to round that up, times 10 to the minus 4 seconds, because it's time period, or of course you could use decimals, which is fine as well, but I'll stick with standard form just so that we can keep getting more and more used to it. Let's just highlight that one as well. Okay, so that question 7 had the additional step of the conversion. If the time period of a wave is 0.02 seconds, what's the frequency? So this time we're back to a frequency working out question. So what we'll do this time is, I'm going to steal it from here. So frequency equals 1 over time period, meaning that our frequency is 1 over 0.02 seconds this time. And that gives us, if we do that calculation, 1 divided by 0.02, we've got an answer of 50. So our answer there is 50. Think about the units, because it's frequency, it's going to be hertz, we should put there as H said. And last of all, the challenge question, which you may or may not have tried, but we'll go through it anyway. If 600 waves go past a point every minute, what's the time period of the wave? So note this time it doesn't just say 600 waves pass a point every second, like we had in 6a, 200 complete waves go past a point every second, and we just knew it was 200 hertz. 600 waves in a minute. We want to get it per second. So you have to think about our first conversion. 1 minute equals 60 seconds. So that means we have 600 waves in 60 seconds, but we want to know what is that in per second. So we'll do 600 divided by the 60 seconds to give us, I'm going to do this anyway because I quite like using this calculator, 10 waves per second, or 10 hertz. Now you go and work out the time period, so we're going to go here, and there we go, t equals 1 over f, 1 over the frequency, comes our time period, 1 divided by 10, or in other words, our time period is going to be 1 divided by 10, gives you 0.1 as your answer. 0.1 because it's time period, and if you standard units everywhere, it's going to be in seconds. Okay, and there ends the frequency and time period questions for this assignment. Check it out against your worksheet. In fact, I'm just going to slowly scroll through the answers again, just in case you want to check back at anything. Makes it a little bit easier than having to pause and rewind and find the right place. And yeah, just check that against your worksheet, and you should have all of the correct answers there. And please message me if there's any questions.